This is just a resource page. This is just like that list that I gave you. It is just a list that is specific for today and for tomorrow and for the day after that. So this is like a picture list that is going to be a little bit more like narrow focused, okay? The list that I gave you before that had like all the different things we could use in a proof, that was like proofs in general. This is like, ooh, this is like nice for today, okay? So you're probably going to use this more today. Once we start doing proofs like later on and they start getting where we could use a little bit more reasons, you're going to be like, okay, this is nice, but I don't have enough of reasons that I could use. You're going to get the list out that I gave you before. Does that make sense? Okay, so for today, you're probably only going to need this. You're probably not going to need the other one, but maybe, don't quote me on that. I'm not sure. Okay, so there are different ways to prove that triangles are congruent. Today, we are going to learn about the first two, okay? Side, 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 angle, side. So if two different triangles have three sides that all match up in length, three sides that are the same, then they have to be congruent to each other. There's no other possibility. They have to be identical. All the angles have to be the same. All the sides have to be the same, okay? So if you look at the triangle and they're like, oh, this side and this side are the same, this side and this side are the same, this side and this side are the same, there is no other possibility those two triangles are absolutely identical in every single way, okay? And we call that side, side, side. The reason I could prove those two triangles are congruent is side, side, side. The three sides are the same. Therefore, the whole triangle is absolutely identical, okay? Side, side, side. Does that make sense? Okay. All right, the next one that we're going to do today is side, angle, side. So this is saying there are two sides that are congruent and the angle that is in between them. So it's not two sides and any angle that you want. It is specifically the angle that is in between the two sides. So it could be this side is congruent to that side, and this side is congruent to that side, and then the angle that would have to be the same could not be this angle, could not be this angle. It has to be the angle that's right in between them. Has to be that one. If those are the three pieces of information you have, two sides are the same, the angle in between them is the same, the two triangles have to be completely identical in every single way. Have to be identical in every single way. They're absolutely congruent, okay? If you show that information, they're identical, you have enough to prove congruence, okay? Those are the only two we're doing today. We're going to leave this to fill out a different day because we're studying those a different day. We're going to move down. Reasons that your sides could be congruent. This is going to be really helpful when you're doing proof. Reasons that your sides could be congruent. It's given in the problem. This is like our favorite thing in a proof, right? They told us at the beginning of the problem that it was given information. So when we're doing that two-statement or that two-column proof, we have our statement, we have our reason. One way we know the sides are congruent is because they told us so. So we say, okay, our reason is that it was given. Another way we know that two sides are congruent is because it's the definition of a midpoint. So a midpoint, if they tell us that something is a midpoint is going to cut a line into two equal pieces. That's the definition of a midpoint. So if they say you have like a long side and you have something that's a midpoint, then you can say, oh, the two different sides, they were divided equally in half. So those two sides are now equal to each other, and I know that because that's the definition of a midpoint. So that would be your reason for knowing that those two pieces were the same. The last is called the reflexive property. So sometimes you have like a big shape that's like divided into two triangles, and you have one line that is shared by those two triangles. So you say this one line is a side of this triangle, and it's a side of that triangle. You can say that that line is the same length in each triangle because, duh, it's the same line. It's equal to itself. Does that make sense? We call that the reflexive property. I like to call it the duh property because duh, it's like itself, so it's equal. Okay? Reflexive property, a side is congruent to itself. So those are the primary things you're going to use today. Reasons that angles are congruent. One, it's given. The next one is vertical angles. You guys are used to that. Then we have alternate interior angles and corresponding angles, which we can only use if they told you that lines were parallel. So remember the two parallel lines and a transversal that we learned on the first day of the unit? If they give you a problem and they tell you that two lines are parallel in the problem, then you can be like, oh, if there's two lines parallel, then I can use those relationships to help me find angles. That would probably be a more advanced type of problem, so you're not going to see a ton of those, but it is possible, okay? Definition of angle bisector, this is the same idea as a midpoint. If they tell you that an angle has been cut in half, then the two halves have to be equal to each other, because that's what it means when you cut something in half, that those, halves are equal. All right, any questions? We good? All right, CPCTC, that very satisfying thing, tells us that once we know two triangles are identical to each other, all the angles are the same, all the sides are the same. So let's go ahead. We have our congruence statement here. So we're going to go ahead and label everything that's the same. If triangle ABC is congruent to triangle DEF, then we know angle A is the same as angle D. Angle B is the same as angle E. Angle C is the same as angle F. So A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. And then we know that AB is congruent to DE. And we know that AC is congruent to DF. And we know that BC is congruent to EF. So if I want to show that the sides are congruent, I can actually put the markings in on the triangle this time. Okay. All right, any questions on the resource sheet so far? Make sense? Okay, let's go ahead and fill in our notes with some example problems. So you're going to leave this out today. It's going to be helpful for doing the problems. So, first one. I took my notes out and I lost them. I lost them already. There we go. Okay. So we've got the first type of triangle congruence proof that we can do is side, side, side. So side, side, side is when the three sides are the same. And so if you can see that side AB is congruent to DE, and side BC is congruent to EF, and side AC is congruent to DF, then your conclusion can be that triangle ABC is congruent to triangle DEF by, and your reasoning is side, side, side. That's all you have to say. It's nice, it's shorthand, it's easy to do. Okay, so here's the proof. Starts off with 3 given pieces of information. That's quite a bit. So first we've got PQ is congruent to ST, so I'm going to label that. PQ, ST, those are congruent. QR is congruent to TR. QR is congruent to TR. And then it says R is the midpoint of PS. So PS is a long line. R is the midpoint. That means R cuts it in half. So if R cuts it in half, what's our conclusion about PR and SR? They're equal in length, right? So they're congruent. Yep. That's what that means. Okay. So the first three statements, PQ is congruent to ST, QR is congruent to TR, R is the midpoint of PS. What is our conclusion? What's the reason for all three of those? Given, given, given. Ooh, isn't that satisfying when those are that easy? Okay. And then why were we able to say, you're going to use your resource sheet for this, why were we able to say that PR and SR are congruent to each other? Definition of a midpoint. Definition of a midpoint. If you just say midpoint, I'd be like R? R is the midpoint, that's misleading. So you say definition of a midpoint because that's a little bit more informative. All right, so now we say triangle PQR is congruent to triangle SRT, and what is the reason? Side, side, side. Whew, that wasn't too bad. Let's do the next one. All right, side JL is congruent to side NM. JL and M, those are congruent. All right, K is the midpoint of JN. Okay, so K is the midpoint of JN. So what does that tell us about JK and NK? They are congruent, okay. K is the midpoint of LM. What does that tell us about LK and MK? They are congruent as well. Okay, so let's go ahead and do this part. So JL is congruent to NM. K is the midpoint of JN and LM. What's our reason for both of those? Given, given. Okay. Now, the next one, we drew it in already. JK is congruent to NK. LK is congruent to MK. What is our reason? Definition of a midpoint. Do we have enough information to say the triangles are congruent? Yes. What's our reason? Side, side, side. SSS. Perfect. Ooh, that was so nice. Wasn't that nice? You guys don't like this? This wasn't fun? Yeah. I love these. I think they're so satisfying. There is something about an argument like this where no one can play devil's advocate. You're like, no, I proved it. You can't even argue with it. I am right. You don't even come at me. You know what I mean? Like, I'm right. Don't even try to say I'm wrong. It's kind of nice. All right, next page. When I was in college, I wrote a paper for a humanities class. Humanities is like history and philosophy kind of like mixed together. And my professor had, he wanted us to write a paper with a certain angle to it, and I did not agree with him. And I'm a passive-aggressive person, so I was like, I'm not writing a paper that has his perspective when I don't agree with his perspective. So everyone else wanted the A in the class, so they were like, I might not agree with him, but I'm going to write the paper the way he wants me to write it. And I was like, I'm just going to approach it like a math teacher, because I already was very interested in math. I knew I wanted to be a math teacher. So I laid out the argument for my paper the way a math person would. I said, like, this is my argument, this is my reason, this is my argument, this is my reason, this is my argument, this is my reason, and my entire paper disagreed with my teacher. The entire paper. He had to give me an A because my paper was so well written that he could not argue with it. He was like, I disagree completely. Very well written. A. And I was like, ha! And all my classmates were like, you're sneaky. You're welcome, everyone. You are welcome. You are welcome. So, this does have application to the world outside of math, because sometimes I didn't necessarily prove him wrong. He still disagreed with me, but he had to give me an A for writing a paper that completely disagreed with what he believed. So that was very nice, you know? That was satisfying. Was that satisfying? Ooh, that was satisfying. All right, next one. You guys, this is completely blank. Completely. You think we can do it? Whew, I think we can do it. All right, let's label things. AC is congruent to AD. Let's label it. All right. CB is congruent to DB. CB is congruent to DB. Okay. And then, can you guys see what the third side is? We already know it's going to be side, 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 because that's what we're doing right now. Can you tell what the third side is? Yes. Well, it doesn't matter, either one of you. Yeah, the third side is shared. It is the same side for both triangles. And do you guys remember what the name of that property is? It starts with an R. Reflexive property. It's the same. Yeah, it's the best property. It's the duh property. They call it reflexive because it's like a mirror. It's like a reflection. Does that make sense? So, like, you're looking at a reflection, you're looking at yourself. It is itself. Does that make sense why they call it that? Reflexive property? Okay. So here's our statements. AC is congruent to AD. CB is congruent to DB. I still haven't used my brain yet. I'm just copying things down. So I've written these two things. What is my reason? Given, given. Whew, that was nice. Now we have to use our brains a little bit. What is the next thing we're going to write down? AB is congruent to AB, and it would be nice to write duh, but we can't. So what are we going to write? Reflexive property. Okay, and now what are we going to write? Yep, the last thing is always what you're proving. Triangle ABC is congruent to triangle ABD. Okay, and the reason for that is side, side, side. All right. Okay, feels like you guys are pretty comfortable with that. Would you agree? Yes? Okay, let's move on to side angle side. Ms. Rice, what timing? It's good timing. It was like 3 examples was perfect. You're ready to move on. You're comfortable. All right. Next one. If we have side AB is congruent to side DE, like in the picture, and angle B is congruent to angle E, and side BC is congruent to side EF, then we can conclude that triangle ABC is congruent to triangle DEF, and our reason is what? Side angle side. All right, let's label things. JM is congruent to LN. Okay. Now, for these types of angles, when they ever give you an angle and they use 3 letters to label it, basically the letter that they're using as the angle is like the middle one. So you always start with your pencil on the first letter, JMN, but the angle that they're talking about, JMN, the angle is the middle one. Do you guys see that? JMN, the angle is the middle one. So start with your pencil on J. JMN, the angle is right here in the middle. Okay? Angle LMN, sorry, I did that backwards. LNM, the angle is the middle one. All right, so we got those 2 angles are congruent. And then what's the thing that is there, but they didn't explicitly say it? You have to see it from the picture. Can you guys tell? Yeah, that middle line that cuts the rectangle in half, that diagonal across, that is congruent to itself. Okay. So we got this triangle on top, we got this triangle on bottom. Now, if it is messing with your brain, is it messing with your brain that they're like connected like that? Does that mess? You guys are all good? You're like, no, I'm fine. I'm fine. You guys are fine? Is it because they already have it written down for you? Is that why you're fine? Yeah? Okay. Now, if they didn't have it written down for you and it messed with your brain that they were connected, you can always just pull the triangles apart and draw them out. So I want you to do this because these are your notes, and this is a good strategy. If it messes with your brain that they are connected, because sometimes when they're connected like that, students have a hard time with that precision piece we talked about yesterday of knowing which letter corresponds to which letter from one triangle to the next. Does that make sense? Sometimes students, when they're connected like that, it's just hard to tell which is which. So now I'm going to go ahead and because the weirdest part is that M in one triangle corresponds to N in the other triangle. You guys see that? I think that would have really messed with our minds if we hadn't pulled them apart. Yeah, isn't that weird? Okay, let's go ahead and do our reasons. So JM is congruent to LNY, given. The two angles are the same, Y, given. And then why were we able to say that MN is congruent to NM? Isn't that weird? Reflexive, it's reflexive. Now, we didn't call them the same thing because they're backwards in the two triangles, but the line is still itself. So even though they are not named the same way, the line is still itself. Does that make sense? It's the same line, so it's still a mirror image. But when you name them in the triangles, you're going to name them oppositely because the angles are not the same. The lines are the same, but the angle measurements are not. Do you see the difference? The lines are the same, but the angle measurements are not. Okay? The reflexive property applies to the length of the line. It does not apply to the angle measurement. Okay? So that's why the sides are labeled differently, but it's still the reflexive property. Okay? So reflexive property. The two triangles are congruent to each other. Why? SAS, side angle side. All right, turn the page. Ooh, there are more examples this time. How fun, how fun. That was a surprise to both of us because I didn't get this far before class started. So we are in uncharted territories now because I have not done these examples yet. All right, AB is congruent to CB. Let's go ahead and label it congruent. All right, it says BD bisects ABC. So this bisects ABC. So how should we do that? Yeah, so angle B, this whole angle right here is cut in half. So this little part right here and this little part right here are the same. Okay? All right. And then what else do we have? Yeah, that reflexive property, which tells us what? Yeah, DB is congruent to itself. So that line that's shared between the two triangles is the same. Okay, so let's go through our reasons. AB is congruent to CB, Y, given. Okay. BD bisects the angle ABC, Y, given. Okay. Angle ABD is congruent to angle CBD. Notice how we couldn't just call those both angle B. We had to use 3 letters to name them. Okay, so ABD is congruent to angle CBDY. Definition, and it's not midpoint, it's the angle version of that. So it's definition of angle bisector, which is the angle version of a midpoint. So same idea as a midpoint, yes. Yes, go ahead and take a class. BD is congruent to BDY. Reflexive property. And the two triangles are congruent, Y. SAS. All right, this one is going to take it up a notch. Are you guys ready? Sure. Whew. All right, V is the midpoint of WZ. V is the midpoint of WZ, so what should I label? WV, and it's technically ZV. Very good. Okay. V is the midpoint of XY. So what should we label? XV and YV. Okay. Now don't cheat. Don't look. Can anyone see what angle is there? What are the angles? There's an angle because we're doing side angle side. WVX, okay, this one, and it's not YVX, it's Z, good, ZVY, and what's the reason? Vertical angles, very good, vertical angles. That's why those angles are the same. Pretty common, that's pretty common in these proofs to find vertical angles. That's pretty common, you're going to see that. Okay, let's go ahead and do our reasons. V is the midpoint of WZ and XY, and what is the reason? Given. Okay. WV is the same as ZV because definition of a midpoint. Okay. They did not do this in the order that I would have done it, but let's go ahead and do the next one. XV, I'm skipping down to number 4. XV is congruent to YV. What's the reason? Definition of a midpoint. So here's the thing about the proofs is these two steps, step 2, 3, and 4, you can put in any order and your proof is right. Okay? So step 1 had to be step 1. Step 5 had to be step 5. Step 2, 3, and 4 can all be changed around. Does that make sense? Because they're not dependent on each other. They just have to be there. Does that make sense? They're not dependent on each other. They just have to be there for the proof to be true. Okay. Angle WVX is congruent to angle ZVY, and the reason was vertical angles. Vertical angles are congruent, or you can just say vertical angles. Okay, and then the two triangles are congruent. Y. SAS. Side angle side. All right, they're up in it again. Are you guys ready? Yes, Miss Rice? Marvelous. Okay. HI is congruent to JG. I was going to say that wrong somehow. JG. So HI is congruent to JG. Let's label that. Okay. HI is parallel to GJ. So what we have going on is two parallel lines and a transversal. This picture is about to mess with my brain. So what I'm going to do is I'm going to make these two parallel lines and a transversal, and I'm going to make it really obvious that that's what's happening by doing two parallel lines and a transversal. You don't have to do that if you want, but that really helps me with my two parallel lines and a transversal to draw it in such a way that it feels more familiar. So honestly, I did this kind of lightly in pencil because I'm probably going to erase it and make it look like two triangles again in a second. But I'm just going to start it that way. Okay, so that's all they gave us. They only gave us that information. Those two sides are the same and parallel lines and the transversal that I could see. All right, so what do you guys notice from that? Don't cheat and look at the statements. What do you guys notice from that? Yes. Okay, JHI, and say the other one again. You're close. So JHI and hold on. This is hurting my brain. JHI and what was the other one? It wouldn't be GJH. Wait. HJG, there you go, are the same because alternate interior angles. Beautiful. You guys see that? I would not let her say it in the wrong order. I made her go back and it hurt my brain. I had to squint. 5 times. And then we got the order right. You probably got the order right before I did. It was hurting my brain too much. Okay, so these two angles are the same because we have 2 parallel lines and a transversal. And these are alternate interior angles. Do you guys see that? Okay. What else do we have that's the same? HJ and JH, and why are they the same? Reflexive. Marvelous. Okay, so maybe leave the 2 parallel lines in a transversal because these are your notes, and that's a good strategy. Okay, so I'm going to leave that. On a regular problem, I might go back and erase it because it might hurt my brain. I am going to go and I'm going to draw these triangles off to the side, again, because these are my notes, and this is a good strategy. If the proof is ever not filled out for me, this is a good strategy so that I can keep my letters and know what part corresponds to what part. So they did make this problem easier on me by filling out the statements for me, but if the statements hadn't been filled out, it would have been hard to figure out what letter was corresponding to what letter, right? That was a little bit more difficult on this one. So it is good to separate those triangles. If you have a migraine and your brain is feeling squinty. You know what I'm saying? You guys feel it? Okay. So once I separate it, do you guys see how it's a little bit more clear? It's crazy how... The only reason I'm not putting primes is because that notation is technically incorrect for this situation. But if you want, now that we know that those triangles are congruent, you could go back and you could mark the rest of the congruency. I know what you mean by prime the letters, but you're still technically wrong to prime them. Yeah. All right. So we've got HI and JG, and what's the reason? Given. We've got the parallel, what's the reason? Given. We've got the 2 angles are the same, what's the reason? Alternate interior angles. You know what is a crazy shortcut for that? I am not kidding, people do that. Alt interior angles. But people do say AIA. HJ is congruent to JH. Why is that? Reflexive property. Okay, and then our last, the triangles are congruent because SAS. You gotta say it with a little bit of a twang because it's satisfying. It goes till 9:18. Stop trying to back up. It goes till 9:18. I got time. You guys are like, class feels over. Putting this away. Class feels over. Okay.